Mortgages. A mortgage is a long-term loan and the property itself is the security. The title of the home belongs to the bank. Now, APR stands for the annual interest rate, typically stated as a percent, and is a term used with financing cars and homes. Now note that payments to a lender are rounded up to the next penny, regardless of whether it's the nearest penny or not. But the TVM solver will round to the nearest penny. Now, the total paid, capital T, on a lowercase t year mortgage with monthly payments, PMT, is capital T equals PMT times 12 times T. This is exactly what we found previously when we multiplied our payment times the number of months. That would be the same thing because there are 12 months in a year times the number of years. Example, mortgage payment number 1. Cassandra buys a house. Her 30-year mortgage comes to $199,596 with 6.8% interest. If Cassandra pays off the mortgage over those 30 years, how much will she have paid in total? Now we're going to go to our TVM solver to find out what the payments are first. The first question we have to find is what the mortgage payment would be. And so let's fill these values in. So capital N is the total number of payments or the total number of compoundings. Those end up being the same. We would say 30 years times 12 months per year. So capital N is 12 times 30, which is 360. I, as a percent, is 6.8 from our problem. PV, present value, is $199,596. PMT, the payment, is unknown, so we will circle solve here. With a future value, FV, of 0, because we're going to pay this loan off. P/Y will be 12 payments per year, since they are monthly. And C/Y, compoundings per year, would also be 12, with payments being made at the end of the period, because we're not told otherwise. So let's go ahead and go to the electronic TVM solver. Remember, you can scan the QR code or click the QR code. That would pull this up. Capital N is 360. I is 6.8. PV is 199,596. PMT is unknown. Leave that blank. FV, future value, is 0. P/Y is equal to 12. C/Y equals 12. Payment at the end. And so we can click solve on the PMT or payment line. And we find that the payment is negative 1301.22. So our monthly payment, our mortgage payment, is $1,301.22. Now remember, it's negative on the TVM solver because that is indicating the direction that the money is flowing, whether it's going into your account or out of your account. So with a mortgage payment of $1,301.22, the total paid over 30 years is, well, let's calculate that. We have $1,301.22 times 12 payments per year times 30 years. And so this comes to $468,439.20. Okay. That is a lot to pay because the next question is how much interest did Cassandra pay? Well, for interest, we can take the total amount paid and subtract the amount borrowed. So in this case, that would be $468,439.20 minus $199,596. And so the total amount of interest paid is $268,843.20. The value of the home is less than the amount of interest paid. This is how mortgages work, especially with a 6.8% interest rate. Example, mortgage payment number 2. If Cassandra wants to finance this $199,596 house with 6.8% interest for only 20 years, the question is, how is this going to change this? So if Cassandra pays off the mortgage over those 20 years, how much will she have paid in total? Well, we'll go ahead and fill in these blanks. The capital N will be 12 times 20, which is 240. I is still 6.8. The present value is 199,596. Payment is unknown, so we'll circle solve on that line. The future value would be 0. Payments per year would be 12. Compoundings per year would be 12, and the payments are made at the end. Now this is the exact same TVM solver setup that I have except for capital N. So I'm going to go back to my TVM solver and modify that. I'm going to change my capital N to be 240 and leave all other values the same. I'm going to click solve on payment to recalculate that. So the payment would be negative $1,523.60. So the new mortgage payment is $1,523.60. Total paid over 20 years will be $1,523.60 times 12 times 20. I'm just calculating that very quickly. So the total paid over 20 years when we multiply those is $365,664. So if we think back to what just happened, in the previous version of this where we talked about 30 years, the question here is how much did we save? How much did we save versus 30 years? Well, if we look back, the amount that we would spend in total over 30 years, $468,439.20, as opposed to, in this scenario, spending $365,664, then that means we have saved, if we subtract those, we have saved $102,775.20. So is it worth taking 10 years off the loan, increasing your payments to actually save most of the value of the home itself? You can decide that for yourself.